You're watching the DSP Leaders Summit on Edgenomics, which looks at the operator economics that support the distributed telco cloud, or telco edge. I'm Guy Daniels, Director of Content at TelecomTV, and today's panel discussion is on the importance of edgenomics for 5G. Now, edge computing doesn't need 5G, but many would argue that the full potential of 5G cannot be achieved without edge assets. So, just how important is edge computing to the 5G business case? Well, let me first introduce our panelists. And joining us from Madrid in Spain is Juan García López, who is SVP Technology and Ecosystem with Telefonica. From London in the UK is Oliver Cantor, who is Associate Director of Global Products at Verizon. From across Washington State in the US is Ian Hood, Chief Technologist for Red Hat. From Ottawa in Canada is Vish Nandlal, who is Vice President Technology, Strategy and Ecosystems with Dell. And joining us from Arizona in the US is Ray Mota, who is CEO and Principal Analyst at ACG. Hello everyone, it's very good to see you all again. Now, the relationship and dependency of 5G and edge continues to attract a lot of discussion. So to what extent is edge computing related to the 5G business case for operators? Juan Carlos, could I ask you that question first?
Well, thank you, Guy. Well, it is unlikely that 5G it can deliver on its promises and cover a good part of the new use cases that it's promising without the edge. Okay, but there are many of these cases that are associated to real-time communication and will require a very low latency. And others are associated to managing a high density of devices that are producing a huge amount of information that needs to be processed. And it can be very costly to be taken to a central place for this processing. And finally, there are also applications that require ultra reliability that will be very probably much more likely to be delivered from the edge. No? So all these cases will be the ones that will bring the full monetization of a 5G deployment. And all of them will require a good solution for edge computing, a solution that combines both very low latency, that combines this possibility to manage huge amount of information, both upstream and downstream, and also enables a very high reliability of the network. So all in all, I think the case for 5G will not be complete without an edge computing deployment that is optimal.
Thank you, Juan Carlos. Oliver, how do you see the relationship between edge computing and the 5G business?
Yeah, thanks a lot, Guy, and nice to be here as well. And yeah, I think I think perhaps we're looking at it to some degree, and understandably, perhaps a bit short-termist in that the edge, in its wider sense, is an inevitable, redistribution of what we think of as cloud computing, or a full distribution of cloud computing, right? The edge exists everywhere today that the CSPs, in a sense, aren't. It's all of the large data centers, private data centers of enterprise, and all the devices and things that are out there, sites and equipment that exist today. When we say edge, we really mean, to a large degree, we mean the cloudification and the utility and the usability that you can get and management out of that you get from a cloud today. And we want that everywhere. And I think if you look at an economic model like water or electricity or any other utility, in the end, it's inevitable that we're going to distribute this power or this resource to where it happens in the real world. In fact, if anything, moving data around with the volumes and to the degree we do today is abnormal, really, for cost. And also increasingly, I think we're only at the beginning of the security concerns. You only have to look at the telephone networks and other resources to see the governments when things get serious. And this is where it relates to 5G. 5G will usher in even more, it's like the starting gun for the real world of IoT. and the real digital transformation, not just in business, but into the public sector, really. And I think that will mean that governments and regulation come in even harder, which will drive this edge concept, this idea that I want and I have to do the processing of my data and the processing and security around my data. I have to do it where it happens in the real world. So I think 5G will be a massive boost for this. And the two will go hand in hand. I think that they're obviously stimulating each other. But the distribution of compute power, which the edge is kind of signaling, is probably an inevitable economic procedure that's happening anyway.
Thank you, Oliver. Ian, you've heard from our two CSP panelists. But how do you see the extent to which edge computing relates to 5G?
Well, as Oliver said, really the key is that processing the data where it has to be done for security purposes makes perfect sense. So it is in every technology we've had, from phone systems to every system of communication so far. We've gone centralized, eventually distributed it, and this is just a continued evolution of that to make utility possible of the data, compute, and network resources. So for me, this is really kind of what drives that business case forward to deliver the services in a secure manner.
Thank you, Ian. Vish, what's your views as to the relationship between edge and 5G?
5G delivers a number of different benefits. We talk about enhanced mobile broadband as really the headline capability that 5G delivers, but more under the hood, what 5G is delivering is a true multi-tenant network. And in order to kind of take advantage of that capability within the network capacity, we need to have some form of adjacent compute to that networking. To realize some of the benefits of things like ultra reliable low latency, which some of the panelists have already mentioned, it's necessary for us to have that compute distributed. It comes at a different economic consideration. Most of the utilization from an architecture perspective comes from pooling, comes from data centers and public clouds. But what we're finding is there's a big trade space relative to the performance side. Performance requires a sufficient amount of distribution so that you can be physically nearer to where, for instance, data is being created. And so it's really allowing us to express the true dividends of 5G by having that edge capacity located closer towards where some of these systems are going to need real-time responses.
Thanks, Vish. And Ray, from your independent vantage point, what do you see? To what extent is edge computing related to 5G business for operators?
Yeah, no, it's the point that everyone touched on. I'll just add on to it that I do agree that some need to view the edge as an extension of their cloud strategy. But I think from the board level meetings that I had is that a lot of these service providers are looking to spend billions of dollars in the industry, right? And what they're seeing initially in some of the regions and markets is that the consumer 5G ARPU, they aren't getting a premium on that area. There are some isolated cases, but they aren't getting enough of a premium to be able to justify the expense and the investment in traditional consumer 5G. So the edge becomes an extremely important role to what some of the panelists talked about related to Industry 4.0, private 5G, and using the edge to be able to develop these new applications that you weren't capable of deploying before, whether it's IoT, gaming, AR, VR, connected cars. So these new type services, the edge allows the service provider to be able to create an opportunity to justify the investment in 5G and not just limit it to consumer there.
Thanks, Ray. Oliver, I'd like to add to what Ray's just been saying.
Yeah, just to add to it, exactly that. When viewed from the service provider perspective, versus, if you like, the CSPs and where they've been coming from, then obviously offering capabilities at the edge is an alternative, right? it's an important place where we are by virtue of having networks that have been built out, in the real world, if you like, or at the edge, as we're calling the real world now, and or the deep real world. And but by virtue of us being there and in all of these sites, in all of these locations, working with the companies, etc., then we have we certainly have the customer book, right? The relationships with large enterprise and government to a degree to go in and to offer these value-added services that 5G and Edge are going to release. And it's certainly true as well, of course, that Ray mentioned that 5G, or I tend to think this happens with most Gs, right? That the amount of investment that's needed to refresh the mobile networks is vast, and our hype cycle is always a bit out of sync. And each time we do a new G refresh, and we often end up with conferences and debates like this saying, "What is the use case?" Right? And lo and behold, there always is one. Well, there always are many. It's just that the investment and the hype has to start earlier because the investment is very large and we need to monetize that as quickly as possible, right? And it is true that it seems that from a consumer perspective, it's not needed right now. The use case isn't as compelling that, people, it would appear from studies done, have a relatively large number of devices that they're happy with and are pretty happy with the streaming services, etc., that they're getting today. So the charge has been towards business, towards public sector to say, what else is there? What are the higher order values that we're going to be able to offer you from 5G and therefore from MEC to realize some of those low latency and those sort of high order business cases. And by high order, I mean more than just, the usual throughput type business type benefits.
Thanks, Oliver. Now, so we've discussed the importance of Edge as it relates to 5G. Juan Carlos, can the Edge and can Edge resources play multiple roles in an operator's 5G strategies? In other words, is it as important to a telco's operations as it is to delivering actual customer services?
Yeah, you are right. Our view is exactly that. No, really, the Edge resources represent an engine for transformation, and it's an engine that we can use for our customers to help our customers in digitalizing their assets, their processes, their businesses, so that they can improve efficiency and competitiveness in their business. We can also use the Edge resources as a platform for other solution providers to distribute the solutions to our customers. It is also very relevant for our consumers, the consumers that we have on the retail segment, so that we can deliver from that Edge positions new experiences for entertainment, like 360 video, augmented reality, virtual reality, new experiences on gaming with hybrid reality, augmented virtual reality. So all in all, I think for our business can be a way, to expand the opportunities for revenues. But it is also true that it can help also operators in the internal digital transformation. So in the digitalization of our assets, in changing the way we run our processes, we deploy, we provision, we configure, we operate and maintain our networks, and can be a mean for us also to increase our efficiency, our agility, and our competitiveness. Yeah.
Thank you, Juan Carlos. I think we should really move on a little bit here, and maybe if we look at the radio access network in more detail. Ian, I'd like to ask you about this. To what extent does virtualized RAN rely on a telco's own edge investments?
Well, when we think about it, the virtualized RAN is really a very specific use case of edge computing, for the network portion itself, and the ability to actually have the flexibility to use that same common cloud platform beyond just the 5G core all the way out to the edge is important to optimize that efficiency in that portion of the network, so that these assets, which are quite expensive to go put out, which we heard from both Oliver and Juan Carlos, that we make sure that that's as efficient as possible. So this is just one of the ways that continues to drive the overall operational cost of the operator's network. And from that, they can take advantage of delivering those services just upstream from that radio access network and put those edge services for the enterprise at the right position in their architecture to distribute those services, make them available to other providers to deliver their services. And back to the earlier point, make sure that the operationalization of this architecture takes advantage of those assets as well.
Thank you, Ian. Ray, what's your take on this?
It's an interesting topic because I think when we talk about the virtualized RAN, we have to understand that not all service providers have the infrastructure or the fiber footprint, right, to justify. So they have to look for wholesale. So there's potential to partner and create this eco environment. And then there's the assumption that you have to centralize. You could actually do a combination with distributed, right? But the challenge that I see initially is a few parts, right? Is that some people that have gone into a virtualized edge really haven't seen the economic benefits. And the reason because of that is because they've created these NFVI, what I call these NFVI vertical stacks, right? And they've been able to repeat the sources. So you have an NFVI stack for EPC, one for IMS, and you aren't able to see the true OpEx benefit. So they need to reconsider the architecture for what we call a horizontal stack, right? Because if you look at it from an architecture perspective, you have to design to say, and when we look at a DRAN model, right, and we look at the cell side expense, you have traditionally the RU and BBU, right, where you have cell side expense, but then you have the backhauling expense. And when you move to a VRAN, right, you're able to then move the BBU and create BBU polling, right, and be able to do a tremendous amount of reduction in the area. So I think the economics are great, but not everybody's in the same roadmap, because if you're trying to do it and you don't own some of the fiber footprint, you have to make sure you create a hybrid architecture so your economics could be done properly there.
Great, thanks. And Juan Carlos, to what extent and does virtualized RAN rely on a telco's edge investments?
Well, a good part of the benefits of the virtualized RAN, the Open RAN architectures, is precisely the centralization of part of the processing that currently is hosted in the base stations. These functions that are centralized are built based on cloud native principles. So they are cloud native network functions, and will require a cloud environment in the edge. And it's an edge that is quite far, is quite close to the base station. So there will need to have an operator-owned edge cloud built for that purpose. And that will bring a significant efficiency to the network. No? It will facilitate the deployment and management of the access network, and will bring not only that, will bring also a lot of agility in addition to efficiency, to the access network. So a new cloud-based environment will be required to host all these network functions, for sure.
Okay. Vish, can I move on and ask you, can a single distributed telco cloud platform, can it deliver everything that a telco needs? And not just 5G, but everything, including 5G?
Yeah, it's a great question. I think that, the answer to that is, a 20 or maybe a $350 billion question. The problem that we have here is that, the edge, while we talk about it in isolation, you can't separate it from the compute system that's in place. The abstraction here is edge plus potentially a private cloud plus a public cloud plus any other kind of compute that may sit along the path. And I think when we think about the affinities of these workloads, we're trying to understand, what type of edge would I design that would be workload invariant? How can it satisfy all of the various workloads that are there? And I think that's a question that's a bit of a false question. I think what we understand is that you do have some workloads that are I/O limited, that require a sufficient amount of I/O capacity. Some that are compute limited that need a lot of compute, and we're finding more and more applications now have other types of issues. They have limits around, for instance, regulatory and privacy issues. They have limits around response times. Those applications tend to benefit more from being deployed at the edge, whereas others benefit more from being deployed at the core. And you may have some degrees of freedom to deploy those applications across that path in intermediate locations. So I think we kind of, like I said, we like to think of the edge as one monolithic set of resources that can handle all workloads. The intention isn't going to be that. A workload running at the edge is by definition going to cost more to run at the edge, just simply because of the cost of the resources that are deployed there, the cost of the site, the cost of the power, all of the other things that really don't benefit from economies of scale at the edge, but they benefit from certain performance characteristics such as latency and response time. So I think maybe the real answer here is that it's horses for courses. You're going to choose when you're going to deploy at the edge. For the class of applications that benefit, that are latency tolerant, that require a certain amount of resiliency, that have privacy requirements, for instance, they're going to benefit from being deployed there. Whereas your traditional applications will benefit from being deployed in traditional data centers.
Thanks. I do like this, horses for courses indeed. Ray, is this the case that a telco edge isn't the panacea for everything? It has its strengths, but it also has its limitations for a telco.
Yeah, no, I mean it's a good answer that he provided there, because it depends where you are in that journey, right? So initially, sometimes in some of the situations where I talk about having telco cloud in a single one, right? It's more about starting to get service providers to think about simplicity, right? Being cloud-like, being cloud native type mentality, so that at least they could start the journey and be able to identify an area where they could create, well, let's say a telco cloud layer to say, this is where my compute, my storage, Kubernetes, and orchestration, and then use that foundation to create other layers. But it's going to vary across, but ideally the economics, right, and the simplicity, if you can get to that level, are just tremendous, right? But it'll be a difficult task to do, though.
Yeah, thanks, Ray. Ian, does the telco edge have to be a cloud native telco edge? Are the two things inextricably linked?
It's an interesting question, and what we see from the 3GPP folks is that for 5G, they pretty much recommended the use of cloud native technologies for that extension to the edge for vRAN as well. So it does sort of go together, that cloud native using microservices in containers on bare metal is kind of the way forward. But there's no question that it doesn't have to be that way, because we all know that there's existing technologies out there. We're also going to see with the economics of what spectrum choices the operators use, do the economics of using an appliance for certain spectrum versus a cloud native piece of technology is the right choice for them in that particular spectrum area. So we're going to see that sort of hybrid picture. I think the real thing is more of a cloud native approach for their business. In other words, use it where it makes sense, build that CI/CD approach for applications, for their security, for their infrastructure deployments across their physical, virtual, and cloud native elements. So now they become much more of a digital service provider. That's really kind of the goal. So it doesn't have to be, but it's kind of the one that drives a better business collection across this set of applications that covers, IT, network, and now we see operational technologies for the Industry 4.0 folks, for healthcare, for any of the manufacturing folks as well, that extends that capability to put these different types of applications on that drive to the underlying hardware through open APIs.
Thank you, Ian. In fact, I'm going to ask all of you the same question. And Ray, I'm going to start coming back to you here. Does the telco edge have to be a cloud-native telco edge?
No, I knew Ian would be all over that question, right? But I'm the external analyst, so I could be more direct. I'm just going to say pretty much OpenStack is pretty much dead from my discussions, right? It's all about going to Kubernetes and containers, and in that environment, I think the importance of cloud native in the telco edge becomes important, because if you look at traditional public-private cloud, when you look at the application coding, it becomes heavy legacy, and for a lot of the service providers that are going to go in that direction, when they ask me what use cases should we consider for cloud native, right, I say everything, right? And the reason is because you're moving to these microservices to be more agile, be more DevOps compliant in that area. So I think it's an important part in this whole journey to be able to be more efficient going forward there.
Thanks, Ray. Oliver, I'm going to come to you next. Do we need to have a cloud-native telco edge?
I think it's been pretty well answered there that, there's an inevitable, evolution of getting things more agile, more flexible, and whichever technology gets us there, right? Linux has been pretty good for doing stuff for a long time. And I would say Kubernetes looks like it's the new Linux. And, putting things in containers isn't really new. It's just what's really hard really is how do you manage that infrastructure, right? You always have an overhead when you've got scale, distribution, multi-tenancy, all of the standard things. It's just the same in Kubernetes, There's a world of DevOps out there that are all building individually, building a coming, I don't want to say nightmare, but a big load of management problems around the tooling, the multi-cluster handling, the abstraction, the day 2, day 3 management of how you do code development. And to a degree, when you were doing that into a single cloud provider like the CSPs, you've got, in quotes, unlimited resource, right? You're just pushing it to a place that executes it. When you're talking about this much bigger problem that we're dealing with now when we say the edge, which is saying, right, I like what you've done in the cloud. Now, can I have that everywhere in the world, please? That's an engineering question, an engineering problem of a much higher magnitude when you've got to now distribute, as we've been discussing here, these capabilities into the real world and wherever the edge may be. And so Kubernetes and all of these things, whichever technology you use, are going to be harder and harder to manage. I don't think we've been mentioning companies much, but that's one of the problems we're very much looking at Verizon. How do you manage the workloads of the future? Infrastructure, yeah, we're building lots of that. We made lots of announcements this week and last week, loads of 5G, and I could try and go on a marketing rampage here with what we've done there. But really, that will, as all infrastructure does, to a degree, commoditize itself in a period of time. But how do you manage the workloads? So yeah, it doesn't have to be cloud native in a narrow definition of that, but it's going to be, it's inevitable that you're going to have it cloud-like, and how you're going to manage that is going to be the real challenge that we want to solve for enterprise and of course consumer as it's needed.
Absolutely, yeah. Thanks, Oliver. Ian, I think you wanted to come back on something that Ray mentioned earlier.
Yeah, of course. I've asked a few times our customers, and our folks that develop OpenStack as to, is it really going to go away or not? And the reality is that OpenStack is actually a cloud-native technology, but unfortunately, a lot of applications weren't actually written properly to live in a cloud-native world. So we put these things in as monolithic applications rather than building them in microservices. And so we kind of moved on from it, said, okay, let's go on to the next thing, which is now, cloud-native microservices, containers, that approach. And really the kind of the thing that's important is making sure that we can operationalize across the existing legacy. Because in some cases, those applications, that even aren't in the network side, aren't really economically viable to move to a cloud native world. I'll give an example of, I've got stuff running on an IBM mainframe somewhere, and I don't really want to change all that stuff. So I build a API linkage into that application, build the new stuff on microservices, but leave the old guy alone. This is kind of the way that things go. So cloud native everywhere, not going to completely take over the world, but it certainly is the way to head forward.
Thanks. And Vish, let me put the same question to you. Does the telco edge have to be a cloud native telco edge?
I think when we think of adoption of any technology, it's important not to separate yourself from what's the fuel that's going to propel it. In this case, it's developers. And you want to be able to adopt the best set of practices that developers are using. And you need to align our edge ecosystem around that. So clearly, cloud native is important. I think the issue is going to be when you actually break down what is, for instance, a 12-factor app, are all the applications going to be stateless? As for instance, there's clearly a set of applications, if you're doing video rendering, for instance, where it's not going to be stateless. If it is stateless, where are you going to persist? Well, you're going to have some constraints around where you persist. You're not going to write an application that runs on the edge and persists in the cloud, because then you destroy the whole reason for being at the edge. So you're going to need to have some form of local storage, and that'll provide yet another constraint as to how cloud native-y your particular application is. So there's definitely going to be some differences. It's not going to be wholesale cloud native. We're going to use a lot of the same principles.
Thank you, Vish. And Juan Carlos, are we talking about the need for a cloud native telco edge to support our 5G services?
Yeah. Well, I think my colleagues already mentioned a couple of points that are relevant, no? Agility and efficiency. And I would like to go a bit deeper in both. No? So it depends on how fast you want to be and agile to be in deploying. No? With a cloud native solution, you can do a deployment of network functions in hours, not something that we were traditionally doing in months previously. It is also very relevant to be cloud, depending on how often you want to upgrade or update your network. No? If this is something that you are going to do once or twice per year, you don't need cloud. But if you think you need to make upgrades more often, probably even every week or every couple of days, then you will need the DevOps methodologies. You will need a continuous integration, continuous delivery methodology. You will need not only that, also continuous verification, continuous testing to ensure that every upgrade is not degrading the network performance and quality. You will also need cloud if you want to be granular in your upgrades or in your updates. The microservice orientation of cloud is also helping you to upgrade only parts of a network functions and not the whole network function. And that can help also very much on agility. And when it comes to efficiency, you need also to think how efficient you want to be in the operational management. With the cloud, I think you are able to give the next step, right, to move to a more uniform way of managing different network functions and network domains. The cloud offers a very uniform way of managing, and also provides plenty of tools for such a management, and are tools that are pretty efficient because some of them are based on open source. And finally, in terms of efficiencies, you need to think also if you want to use cloud. Also, when you are thinking about a dynamic way of scaling up and scaling down your capacity. With cloud, you can do this very easily. Without cloud, it is also somewhat complex and consuming, time and effort consuming.
Thank you. And Oliver, a very quick final word to you.
Just a counter idea. We're very drunk on the idea that we want lots of agility, right? It's very, very appealing for business, and it sounds like it's the right thing to do. But we must always caution that very good engineering, and by that I mean things that last for a long time. If we want that, and that's what we've built in the core of our networks, telephone and beyond into data networks. If you want that, then we've always been able to upgrade things and control them and do them with processes, people, culture, and the tools that we've had. So just adding and layering on lots and lots of new cloud native and DevOps and all of these practices doesn't necessarily get you the quality that you want. And, you know, as important as saying that everything needs to move to these new methodologies is that we impose good engineering principles and long-term system engineering principles to the development of all of these capabilities.
Great. And Juan Carlos?
Yeah, well, yes, would like to make a short observation on my colleague in the last comment he made. Well, and that is true, no, but the thing that also we have new features coming to the network with 5G, like network slicing, that will imply that the telecom operator will have to build a logical network dynamically and on demand. Okay, and this is something that will require that you have totally different processes for this provisioning, for the operational management of the slices, and you will need this slicing to happen in the radio access, in the transport, in the core. So you will need all these network domains to be cloud-based if you want to make this dynamic management of capabilities, of network capabilities.
Great. Well, it's always good to end on a cautionary note, but we are out of time. I'd like to thank all of you very much indeed for taking part. A reminder that we have many more interviews, panel discussions and analysis programs as part of the Edgenomics Summit, and they're all here to view on TelecomTV. We also have a live Q&A program which is scheduled for 4:30 p.m. UK time today, where we will be taking your questions. There's a form here on the website that you can use to submit them, and hopefully we'll build on the discussions and the themes that we've just spoken about. There's also a link you can use on the website that you can add the session to your calendar and receive a local time zone reminder. But for now, thank you very much for watching, and we hope to see you again very soon.